N obviously relates to the number of moles. Okay? We can't use M because it's the unit for every other thing. But N is the number of moles. V is for volume. In our gas laws originally, did I make it clear that it doesn't really matter the unit as long as on both sides of it's consistent? Did I talk about that? Okay, good. So our volume could be measured in liters or it could be measured in milliliters. It doesn't matter as long as they match. Okay, and that's true for the next equation we're going to see as well. But let's try one here. It says 2.54 moles of argon gas occupy 89 liters. What volume will 2.10 moles of argon occupy under, I showed you the answer, under the same conditions? So this is showing us, I guess not necessarily a change in quantity, but it's looking at what would the volume be if our quantity were to change. Okay, I guess you have to think about it kind of like that. All right, so it's N1 over V1 equals N2 over V2. So 2.45. Grab your calculator out if you don't have it already. 89 liters. So I'm just going to leave them in liters. There's no need for me to change it. So in this scenario, how do we solve for V2? What's the math that we need to do?
You need to get V2 alone.
Right, but do you remember the rules for math with proportions? Cross multiply and divide. Right? Cross multiply, divide. So cross multiply, then divide. Were you guys taught that?
I mean,
yep. I just
algebraically.
Okay. Well, that's not what I said. Cross multiply, then divide. You got it. Easy peasy. What is it? 76.3 liters. Units would be liters, since my original volume was measured in liters. Okay? And that's what we said it should be, which is good. All right, we already did Guy-Lussac's law, so I'm going to skip over now to combined gas law. What do you think that means? We just combine them all together. Okay? Put all three together, except not Avogadro's law. Right? The combined gas law was we put Charles, Boyle's, and Guy-Lussac's all together. And we could look at a before and after picture involving pressure, temperature, and volume. Okay. P1V1 over T1 equals P2 V2 over T2. So as long as you know this one, you can solve any problem, right? As long as you know this one, even if they weren't given a temperature, you could just leave that off and you'd be left with, which one?
PV.
Yeah, which one is it? Boyle's, right? If you had constant pressure, you could leave that off and you'd end up with Charlie Brown's under pressure. Can you leave off pressure? Did I give you those little nuggets in the video too? Somebody taught me that way.
I don't like them.
I'm going to give you a second to collect what information you need and get written down what you need, and then we'll start in on the problem. Okay. What is the one unit I said always has to be something particular? Did I tell you that? Temperature always has to be Kelvin. Always, always, always. Pressure, it can be atmospheres or millimeters of mercury or whatever it is, as long as it's consistent. But temperature, since there's an addition component to our conversion, that means we have to have them the same, right? If we're doing pressure conversions, we just multiply by the same thing on both sides. But temperature has an addition component, so it has to be the same. So here, if I start writing it out, here's V1. The temperature of the balloon and the pressure was 1 atmosphere. So here's 1 atmosphere times V1 over T1. So what's the conversion from Celsius to Kelvin? Plus 273. Good. So I'd have 293 Kelvin for my T1. The balloon rose 3 kilometers into the sky. Don't care. The pressure is 0.667 atmospheres. 667 We're solving for V2. Temperature's 263. Right? You see where that 263 came from? Negative 10 Celsius plus 273 gives me 2.
Where did you get? I'm a little confused on the ATM.
So this is the pressure.
Mm-hmm.
I just wrote the unit on the left side just because, but it's just 1 atmosphere. That comes from the pressure was 1 atmosphere right there. Okay. So this is P1 V1 T1 P2 V2 T2. Okay, so algebraically you can go about however you want to solve this. I like to solve the whole side, and then I'll multiply, divide. That's how I like to do it. There's lots of different ways you can solve the algebra here. Do we have an answer yet, or not quite?
2.42
Very good.
liters.
Good. V2 equals 2.42 liters. Okay, so combined gas law just means we put everything into 1. That's it. Okay, here, this was meant to throw you off. The balloon rose 3 kilometers. Right. Where would that have fit into our problem? Nowhere. So don't let it freak you out, okay? Not going to fit anywhere. Don't try to fit it somewhere.
So does pressure not change with how high something is, like in the air?
It does.
Well, it changes.
It did change from 1 to
okay.
0.667.
But we can't say that every 1 kilometer or every 3 kilometers is 6.
Right.
Minus, yeah.
Right, and not at a certain rate. All of that has such an effect, or temperature has such an effect on that, that you can't give a steady rate change.
Since one of the problems says for the ATM, like it was like...
Good. Oh no, I did a thing.
Is that an answer?
No, I did a thing. Okay, I don't know how to go back.
We're back to Avogadro.
Yeah, we do come back to him.
No, I don't like
Can't get enough of him. Oh my goodness. It's so crazy. Stop. Okay, there we go. Sorry. There we go. Now we're good.
Oh, you don't.
No, we're not good.
We've gone to school too.
It's our first day back.
Precisely.
Exactly. Same. Just kidding. I don't play video games.
Why not? Really?
I don't know.
She has
I got a life.
stuff to do.
I'm just kidding. I'm just kidding. Not really kidding. Does the Wii count? I'm pretty good at bowling on the Wii. Oh shoot, my video is still recording, so I guess people watching will get to hear about me in video games. What'd you say? I've had how many years to practice? Yeah, it came out like 2008 or something. I don't know. Probably before that.
12.
I got 243.
All right, here we go. P1 times V1
I wish I knew.
over T1.
So you just
273 plus 24.5. 4.250 times.
How'd you get that? I got. Oh.
If it were me and I was going to do the algebra, I would solve this whole side. So 2.40.
That's what I did.
Let me do that. 2.40 times 3.25 divided by 297.5. Okay, so on the left side of the equation, I think it comes out to be
26.
right.
And then I solved,
right here, 0.0262.
And then I solved the
Switch these two places.
top two.
Okay.
Oh, you just do that?
Yeah.
It's 2,431.
243. 243.3 Kelvin.